Hi, my name is Greg Davis, and I'm a senior consultant in professional services based in Sydney. And today I want to talk to you about how you can build some cluster node awareness into your vRealize automation solutions. So through this, I'm going to be talking about a combination of some solutions which use vRealize automation native, and then some additional challenges where you may need to go into your vRealize orchestrator and start looking at some workflow solutions. So this is just an overview of the agenda I'm going to talk through. So first of all, I'm going to look at some solutions which use the Vra Blueprint and adding additional features onto your blueprint to do some cluster-aware operations. And then sort of looking at some of the challenges that you may have with that approach and how you may then need to start looking at subscription-based solutions and talking through the vRealize orchestrator as well. So I'm going to look at two scenarios, what I'm calling cluster awareness two ways. And the first scenario question I'm looking at is, you've designed a vRealize automation blueprint which has several cluster nodes on the canvas. And that's all well and good, but now you want to integrate something which is like a cluster-aware operation. For example, you want to put a load balancer into your blueprint so that after your web server is built, they actually translate some information into your load balancer, and you get your load balancer set up, and it's balancing web traffic across your nodes. So this is the simpler of the two scenarios I'm going to talk through. So here we've got the Vra Blueprint Canvas. So this is like your design area where you're putting together your components that your customer will then request from the service catalog. So at the bottom of the canvas here, you've got, you can see a vSphere. Sorry, by the way, this is a vSphere virtual machine type of deployment build. At the bottom of the canvas, you can see your two database servers. And they're actually one database server per site. And then moving up the canvas, you have your web servers. And then at the top, what I've done is I've dropped on, actually in this case, it's an X as a service blueprint, which is your F5 load balancer. But you could also have on your blueprints one of the out-of-the-box constructs. You could select on the left network and security and then add your NSX load balancer. In this case, it's a third-party load balancer, so I need to use an XAS blueprint. And you can see that these lines here that are connecting the load balancer to the other components in the blueprint. And what that basically means is this load balancer is not going to start to deploy until all the other components in your composite blueprint have finished. So just drilling in a bit deeper, this is looking at the actual XAS blueprint itself. And you can see how we have like a couple of steps there, which are actually the virtual machine names, which I'm passing through from the web server node into my load balancer. So this is how you can do property binding. So this is one way, like the first way that I'm getting information from my composite blueprint nodes and passing them into my load balancer. So I'm getting some awareness of the overall cluster construct and then passing it into my load balancer object to then be provisioned. And what's also important is, yeah, I made a point at the bottom there. This is actually capturing the host names of the two web servers at the end of provisioning. So I've got a custom workflow that generates a customized host name during machine building, and these properties have been updated dynamically and are now getting passed into the load balancer with the customized host name that my customer wants to use. I'm sorry, just a quick step back. I forgot to mention all of this information that I'm discussing in this mini presentation is based on a project I'm currently working on for Westpac and IBM. So I'd like to say thanks to them for providing me access to their environment and taking these screenshots. So my XAS blueprint is actually tied to a vRealize orchestrator workflow. So this is showing you now into vRealize orchestrator the information of the actual workflow. And you can see like my first step. So I'm taking these two inputs, which are the web server host names. And from there, you can actually build out all the other information that you might need to gather from your virtual machine deployments. So you can see there's this little function at the top. And what I'm doing is I'm starting just with the host names, and then I can build out the VRA virtual machine name, and I can get the entity, and my IS host, which is like a plugin to VRA. And then from there, I can get the virtual machine properties. And what's very powerful about this is from the property set that I've then got, I can get any information from the machines that are in building state that I might have written down through various vRO workflows. So just stepping back to the previous slide, I don't really need to bind any other custom properties into my virtual machine, into my XAS blueprint. I can get them all in my vRO workflow. So if I need to extend my XAS workflow capability in the future to get more information from those virtual machines for load balancing and so on, I can just extend the capabilities of my workflow. I don't need to touch my composite blueprint. And then this screen is showing you like the final solution. So if my customer had requested that composite blueprint in VRA, this is what my deployment actually ends up looking like. So you can see the load balancer is actually part of the deployment. It's an object that's been created as part of my deployment. And then the screenshot, that little box at the bottom is showing you that I can actually execute a customized day 2 action against my load balancer, and it'll actually show me, it's actually showing me that the pool members have been added to the load balancer, which I fed in from the composite blueprint. So that's a cool way that you can integrate with using VRA out of the box and a little bit of vRO code and get some cluster operations happening. But what happens if you maybe want to execute a cluster operation that's a little more complex? I mean, you want to get information from all your cluster nodes, but during the machine provisioning phase, maybe not when the machines have completed building, but maybe partially completed, or maybe even when one of the machine fails and another one has succeeded to build. And the example I want to discuss now is composing a cluster email, which means like a consolidated email which is going to show the information of all the virtual machines that I've requested, or all the cluster nodes in my SQL Server deployment. And it's just like a single email rather than multiple emails for each virtual machine node. Now, it might sound like that's fairly simple to do, but there are some challenges. So for those of you who are aware of the machine provisioning lifecycle states in VRA, there are quite a few. And this screenshot is pretty busy, and it shows the machine lifecycle building states for a vCenter virtual machine. And these states are transitioned through for each one of my virtual machines on that canvas that I showed you previously. So each machine will go through these states. So the challenge is I may want to send my email in like post machine activated that I've highlighted there on the screen. But how do I consolidate all the information for all the nodes so that I can put it all together into an email? My virtual machines may not necessarily hit that workflow at the same time. They might all be in different places. So I need to have some kind of mechanism to compile all that information and have some kind of awareness in my workflow that all my nodes have hit the workflow and the information is ready to send. So the first step in doing this is I need to create an EBS, event broker subscription, which is a way for me to tap in and do something during my machine building lifecycle state. So just stepping back a second, so I'm basically interested in sending an email out during the post machine activated state, which is kind of right at the end of my building lifecycle, before the machine is powered on and it's ready for my customer to use. So what I'm doing here is I'm creating a subscription called, and I'm naming it out after the state, post machine activated cluster email notifications. And it's, as you can see at the bottom, it's a machine provisioning type of subscription. So that means it's going to get executed during the machine lifecycle. And if I drill into the details of the subscription a little more, you can see that I've set up some conditions for the subscription to execute. So the first one is that the lifecycle state must be machine activated, and it's the post state, the post state phase. And then the third one is basically a filter. So if I just had the first two parameters and not the third, then this subscription will actually get invoked for every single machine that I have, or every blueprint that I have, virtual machine type, that's in VRA. So we obviously don't want that. We want to narrow it down just for cluster nodes. So I have a custom property filter there called cluster email notifications, and it's looking for a value of true. So if I step back to my composite blueprint and we look at one of the cluster nodes on the composite blueprint, you can see that I've added a property group which has the same name as that custom property. It's got an enable enable cluster email notifications name, but within that property group I actually have that custom property on the previous slide with a value of true. So in this way I can easily, it's kind of like I can easily drop my subscription onto any machine on my blueprint that I want to execute that subscription for. So it allows me to easily drag and drop and remove subscriptions, and I don't have to like manually type the custom property name in. So what I've done is I've added this property group to all my machines on the blueprint, and that means they will all execute that subscription during that lifecycle state and phase. So if I now step into vRealize Orchestrator, this is the actual top-level workflow that subscription is calling. So this is just a little overview on some best practices of vRealize Orchestrator subscription layouts that I like to use. So it's a good idea to have your top-level, quite a clean presentation. And then you can see there are a couple of snap-ins defined there. And what the snap-ins are, they're the actual workflows that do the job. Now you could put all your code at the top level and just have a single workflow with like multiple actions, script tasks, etc. But then that means that that operation, such as send cluster email, is very much tied to that subscription. Now I might want to use that snap-in for other workflows in the future, or maybe during deprovisioning. So in this way, having the top level like this, and then if I drill down into the cluster email snap-in, now you can see from my snap-in level, this is actually starting to execute the code that I want to call. So the first step in my workflow, I'm actually checking for some machine properties on the virtual machine that enters this workflow. And if I just drill down into that code a little more, you can see what I'm checking for. I'm just double checking that custom property we just talked about is actually defined in the workflow. And then I'm also making sure that for this particular machine, there's a property I'm checking for cluster node count, and I'm making sure that there are more than two cluster nodes in the actual requests. Because say for example, this snap-in accidentally got executed by a virtual machine that was just a standalone in a blueprint. I want to make sure that it doesn't go through and do all the tasks that are meant to be clustered. So as you can see here, then it goes to a branch called properties defined, and if I haven't defined the right properties, it's going to go ahead and exit out of that workflow and it won't continue on. So just stepping through the workflow a little bit more. So what you've got to bear in mind is this workflow is actually going to be hit by every single one of my cluster nodes, right? But my end goal is to send just one cluster email, so I have to put some intelligence in to, first of all, gather information about each of the cluster nodes. And then I need somewhere to store that information so that the last cluster node that hits this workflow can actually go ahead and do the actual email sending. So as you can see here, there's a couple of actions which are gathering information from the cluster nodes. And if I step into the first one of that, what it's doing is it's creating a JSON file which contains various information about that particular cluster node, such as its host name, and lower down you would have like its IP address, and we've got the site that it's going to be deployed to. And that's formulated in a JSON structure so that I can very easily parse it in JavaScript. So it's very flexible and easy to step through. And then the second action, what that actually does is it writes to a resource element, which I often use as a caching area in vRealize Orchestrator to store transitory data that I might want to query during a build, during the build process or machine provisioning for a virtual machine. So this resource element has been created, which has a correlation ID. You can see there's like long number on the left, and that actually relates to, it's a common component that's across all my nodes in my blueprint. So this is pretty cool because it means that every node that hits this workflow, it can go ahead and write to the same cluster node JSON resource element. and it knows how to find it because they all have a common correlation ID. So you can see some of the details in the viewer window there of the resource element. You can see how I'm caching that JSON that I just constructed in the previous action. And then the next member that hits this workflow, like in total we would have 4 if we were looking at the SQL example on my blueprint earlier. Each one of those is going to add like a block of JSON relating to its particular self. And that would be under the members, and an extra array component would be added. So that's great. So now I'm kind of at a point where, for example, all of my nodes have hit those workflows and they've cached the information that we need to send out the email. Well, the next thing I need to do is basically, I want to make sure that all my cluster nodes don't actually send the email out, right? So I have this workflow, which this is where some more of the node awareness comes in my workflows. So I've got a workflow which is detecting how many nodes have actually checked into this workflow and done their work. So if we delve into that, nodes checking cluster nodes to workflow, you can see what I'm highlighting here is there's like a lock element, and this was also would have been present in the previous action that I highlighted. So what this is doing is it's making sure that we don't have simultaneous writes to the resource element that I'm accessing, and it's locking based on that common correlation ID that I talked about before. So if another node happens to come in and start executing this workflow at the same time, it's going to wait until the first node has done what it needs to in the resource element before going ahead and trying to update it. If we have simultaneous writes, then you could end up with some corruption in your resource element. So stepping through this workflow a little bit more, what happens in the end of the script task is it's actually writing to that resource element and updating a value called cluster emails nodes checked in, and it's updating that a counter in the value of that property. So each successive node that checks into the workflow will increase the counter. And then I've got some code like down there, which is basically looking to see how many nodes are actually in this deployment, and then comparing it to the counter value. So for the first and second node, the number will be lower, so this workflow will return false. But for the last node that hits the workflow, this will actually end up returning a value of true. So if I step back to my main snap-in workflow, you can see that I then have a decision point here to say, oh, have all my nodes checked into the workflow. So for the first 2 that have gone through, that would come out as a negative, and it would go down to that red arrow, and nothing else further is going to happen. But the last node that hits my workflow, it's going to step on and go, okay, I'm the last node that checked in. I just got to return true from my check-in workflow. So I'm going to go ahead and start actually composing this email. So stepping through now, we'll have a look at how the email composing workflow works. So what I'm doing here is I compile the top sections of my email, so such as like the deployment name, who requested it, what time they requested it, and their VRA business group that the requester is a member of. And then there's an action here you can see called, which is actually called add cluster nodes to the email JSON. And what this is doing is also building up a JSON file. So this is going to go to my cluster nodes JSON that we were looking at earlier, cached in the resource element. And it's going to get each node out of that resource element JSON and tag it down to the deployment information. And then finally, so the output of this vRO workflow is my cluster email JSON, which contains all the information, like the body of the email, that I want to send out to my requester. So you can see at the top, I've got like my username, and then I got some sections which refer to the deployment name and so on. And then you can see members down there, and this is where I've tagged my virtual machine JSON backend and to create the final cluster email JSON. And just stepping back a few notches again, if we look at this workflow, you can see the last part, which is called send email. What that workflow actually does is it takes the JSON and sends that through. In this case, it's actually being sent through to a third-party system, and that system is managed by IBM BPM, and then sends the email to an email system. And it constructed an email which looks something like this. So this is written with HTML, so you could very easily parse the JSON in your own workflow and send it directly to the email server should you choose to. So you can see like my deployment information, my cluster nodes, and everything's there in one place. So just a bit of a summary then on what I've talked about. So we've looked at how we can execute cluster operations and get some cluster awareness within the vRealize automation composite blueprint itself, and using an XaaS workflow and take information from my web nodes. And then your load balancer becomes part of your deployment, and which you can execute day 2 operations on. And then when you have a more complex scenario where you need to compile information, detailed information across all the nodes, and you might want to do that actually during the build phase, then we've had a look at how we need to use subscriptions, and then using resource elements to cache the information, and having some kind of check-in property so that only one of your cluster nodes actually performs the operation. So thanks very much for your time, and I hope you found this useful.